Hello, I'm Robert, and I'm a science blogger, and I'm a software developer, and I've been interested in the humans in space ever since before Apollo 11. I remember that as a child, and in the last few years, I've been especially interested in planetary protection, and I wrote a book called Touch Mars, an online book which you can see on Kindle as well, which, as far as I know, is the first complete book, the second complete book on planetary protection. The first would be When Biospheres Collide, by a history of the NASA Planetary Protection Program. And so I'm especially interested in this, and I'm very surprised at what NASA have been doing here with this new plan to classify most of Mars like the Moon. And so I want to explain the problems with this. And first of all, it's possible that they're thinking about doing a sample return mission by 2030. And this may be a factor behind why they want to reclassify it like this, because in principle, according to the Outer Space Treaty, if that was the only thing that applied, and if large areas of Mars were classified as like the Moon, then it would mean that you don't think there's any life there, and so there'd be no problem in returning a sample. However, and luckily for those of us like me who are concerned about what might happen if you return a sample from Mars to Earth, we're no longer just protected by the Outer Space Treaty as we were at the time of Apollo. There are numerous laws that protect Earth. So this is not going to make any difference to that. It's really neither here nor there what is classified under the Outer Space Treaty. And I had a look, for instance, and it's not just a little bit of paperwork, annoying paperwork that would take 20 years to complete. There's an actual reason for this. The life on Mars could potentially be hazardous to humans. And a simple example that I've got here is Legionnaire's disease, which is an infection of biofilms. It's not adapted to humans. And yet, it's a disease of humans as well. It just sees our lungs as a born biofilm. Now, some strains of this are now adapting to our environments, spread by humans who are infected by it, and then they can take it up again from the environment, infect again, and it's somewhat adapting. But the same could happen with the Martian life. If some Martian life invades the lungs of an astronaut on Mars, and sees the lungs as just being a nice warm biofilm, and then it could spread to other habitats inside, and then back to humans, and get a little circle like that. And then it's entirely possible that Martian life is not related to Earth life. If you listen to space colonization enthusiasts, will tell you that it's the same. It's going to be related. Some of them will anyway, but they haven't convinced astrobiologists who invent instruments to look for all forms of biochemistry. And it's just the astrobiologists say that it's possible that Earth life could be mystified. That Martian life could be it's possible that I got that the wrong way around. That an alien biochemistry could be mystified by Earth life. It's also possible that Earth life hasn't evolved any resistance to it, so it's the Earth life that's mystified, never having encountered it before. So it can go either way. And our lungs might offer up no resistance at all, not even recognizing it as life, as it munches away at them. And antibiotics would likely do nothing to stop life based on alien biochemistry, because it's targeted to particular cell processes, and that's how Earth microbes evolve resistance to antibiotics. So alien life most likely would naturally be resistant already, because it just doesn't have the same cell processes. So when space colonization enthusiasts might think they just breeze through all the legislation, but legislators wouldn't ignore arguments like that. And even if there were no objections and no problems with it, then if looked through the article by Margaret Race of the SETI Institute, and then I worked out from that, I just tried to get the dates from that, and I wrote this article about it for my Science 2.0 blog. I can't see them returning a sample from Mars if they don't know what's in it. It's very different if they know what's in it, but if they don't know, and if they're trying to protect against all possible alien biochemistries when we've never even encountered a single non-terrestrial biochemistry before. And you want to be sure of that before you return it to Earth without knowing what's in it. And then looking at the last 2 sample return studies, I can't see that being completed before 2040, even if everyone was totally in accord with you and there were no objections from anyone. And in practice there might well be objections. So this is not going to make any difference. What they do with the Outer Space Treaty is neither here nor there, because it's all the environmental laws. And if you haven't looked at this up, just take a look at Margaret Brace's article, which also I summarise some of it in my post there. So yeah, I'm not worried about that direction. But in the forward direction, this is very different. So this is the relevant thing here. So this report said that we should map parts of Mars as being category 2, just like the Moon. And this means that you could send dirty spacecraft there, and it wouldn't matter, because the claim is, and if you look at the definition of category 2, the claim is that without checking it closely, where there's only a remote chance of contamination carried by spacecraft could jeopardize future exploration, and this is defined remote chance of the absence of niches, places where terrestrial microorganisms could proliferate, and or a very low likelihood of transfer to those places. So to categorize that as category 2, you'd be saying on the map, and this would be the 2014. They only did the 2014 review in the report, and it's led by a geologist, planetary geologist, not by an astrobiologist. And they don't seem to be aware that even as the 214 review report was in the process of being produced, then both NASA and ESA were not entirely happy with it, and they called for a 2015 review. And the review found numerous problems with the 2014 report. And one of them was that they said that maps won't work. They said that maps can only represent incomplete knowledge, because the habitats just aren't visible from orbit. And that's all we have, really, for most of this. There's very little ground truth that we have. And they said, in general, the review committee contends that the use of maps to delineate regions with a lower or higher probability of host special regions is most useful if the maps are accompanied by cautionary remarks on the limitations. They can only represent current and incomplete state of knowledge for a specific time, knowledge that will certainly be subject to change or be updated as new information is obtained. And that's in 2015. And we've come across many new ideas for habitats on the Mars surface since then. And this is an example that was they already knew about back then, the recurrent, although we're continually finding more of them. And these are these little slopes that extend seasonally during the year. They start off in the spring, and Martian spring, then they spread out during the summer, and in the summer they broaden, then they fade away in autumn. And it's very difficult to see why this is happening unless there's some connection with the seasons and the changing temperature. And it's not the dust storms that are doing this. And if it's to do with changing temperature, it basically seems to be when the surface reaches about freezing, about the point at which water would go liquid, and it's probably actually colder below the surface, but salty brines must seem likely to be in some way relevant. Now, and I'll come back to a bit. There's some papers since then suggest that dust flows are connected with this, but they don't rule out the salty brines. So they made, there's one example, 58-hour cells were found in Mount Sharp close to the Curiosity landing site. Here are 3 of them. And these were not known until after Curiosity landed. They were found from orbit, but they hadn't looked so closely in order to find them until before Curiosity landed there. And there they are, you see these little streaks, and they seem to be quite possibly related to the same sort of thing. There might be streaks of brine there involved in their formation. The darkness is not a damp streak. These photographs taken in the afternoon when it's very dry, and if there is any movement of brines that actually dampens the surface even slightly, then it's dried out by now, by this time of day. Because it's just the orbit of the satellite doesn't permit them to take photographs that close in the early morning. it's a sun-synchronous orbit of a particular type. And it's only close to Earth, close to Mars at that time of day. And so, and then it's a little bit more, I'll talk a little bit more about the Mars. I talk about it, I'll bring it up later there, but I'll do it here. The dust cascades explanation. So this, if you just go by the news, then you tend to think, oh, it's just dust. But and there wasn't the other points on it weren't very much treated in the news stories. But I searched the academic literature on it, and they are consistent with dust cascades, but the hydrated salts and seasonal nature of them can suggest some role for water in the formation of these dust cascades. It's hard to make sense for dust cascades without there being some role for water. It may mean less. And there's some various difficulties with them, such as the rapid fading away of the streaks at the end of the season, instead of the usual decades that you would get if it was just dust. And the lack of explanation of how the dust gets supplied from the top year after year, because it's very steep slopes. And it's also a major question for the brines. But and then they did find that they seem to traverse bedrock rather than the regolith of other RSLs. And if water is involved, then there must be substantial amounts needed to stay lengthening through the season. So we're still thinking about fairly substantial amounts of water. So this is not here. I'm summarising. So I'm working on a paper that I want to submit to an astrobiological journal. It's very long. I'm probably not going to include all of this. Sorry, I dropped something on the floor. Most people. I'm probably not going to include all of this if I can actually publish it. But I did a fair bit of background research, and so I'm quoting from that here in my rather long paper here, which I'm hoping eventually to publish a shorter version for try and get it published. But this is just background information I'm using it for here. So anyway, to go back here, so this they found these maps are very rather dicey way of knowing, and it just this report, they don't seem to be aware of so many things. At least there's no mention of it, no awareness of this review in 2015. And also there's been a vigorous debate in Nature and in Astrobiology journal, and both sides are in agreement there's a significant possibility that Earth microbes can contaminate Mars. So why didn't they mention that? This report saying good classified as category 2, meaning there's no possibility of that. But both sides in this debate, they would surely not support classifying Mars as category 2. Rather, it's about whether we should reduce the sterilization requirements in order to study the habitats quickly before the human missions get there. And both sides assume that the human missions are going to make it impossible to study them in pristine condition. You can have a look at these, if I've got links to them here. You can go and read them for yourself. And they're arguing for relaxing planetary protection, and these are arguing against relaxing it. Both sides are in agreement that if the humans get there, then they will irreversibly contaminate Mars with Earth microbes. And then the other thing they don't mention are the many potential surface or near-surface habitats that have been proposed since their latest site in that report is 2014, and there's been roughly 1 or 2 new proposals for habitats on Mars for every year since 2008, which is when there was the breakthrough from Phoenix. And this is Nilton's Benno, and he's trying to simulate the conditions that may have formed the droplets that formed on the legs of the Phoenix lander in 2008, where there seemed to be droplets where droplets of what looked like a liquid, but unfortunately they couldn't analyse it because it's in a place inaccessible to their instruments. But he simulated what seems to be them, might very well be what Phoenix saw, and just after a few tens of minutes of salt in contact with ice, then these little droplets of water formed, and droplets could potentially be habitable to microbes. And he says here itself it's a small amount of liquid water, but for bacteria, well, let's just play his bit. Is this set at the right time?
Count velocity phase detected. Altitude 40 meters.
148.
The Phoenix mission was very
There we are.
because we don't see the formation of liquid. If we have ice and then the salt on top of the ice, in a few tens of minutes, liquid water form. Our measurements clearly indicate that. And it's really a proof that the liquid water form at the conditions of the Phoenix landing site when the salt is in contact with the ice. Based on the results of our lab experiment, we expect this soft ice that can liquefy perhaps a few days per year, perhaps a few hours per day, almost anywhere on Mars. So going from mid-latitudes all the way to the polar region. This is a small amount of liquid water. But for a bacteria, that would be a big swimming pool. A little droplet of water is a huge amount of water for a bacteria, right?
So that's the that's and this. It's really quite exciting that there could actually be habitats for life on Mars, and so that's what they found. After a few tens of minutes of salt in contact with ice, that's not very long, then this liquid water, droplets of liquid water formed. And now that is not in the area where Curiosity is, but where Curiosity is, then they discovered this using this Nilton Renault is in charge of the weather station on Mars. He was also a principal investigator for the Phoenix mission as well. He's an expert on water on Mars. He's written a big review paper on the many different ways that you could have liquids forming on Mars. And the Curiosity, this weather station on Mars, they have discovered variations in humidity that are very intriguing, that the humidity sensors, and as the days progress, so what to have it written out, the summary of they found, that when it went over the sand dunes, the air above them is drier than it normally is. Then when it leaves the sandy areas, the humidity increases. So why should travelling over sand make the air drier? And their answer is that they think hydrated brines, hydrated salts form beneath the ground. And it goes from below 15 centimeters down to about 50 centimeters. So quite a lot of hydrated brines. Hydrated salts. These brines form, and that it would be too cold, but at the top temperature is 50 centimeters, would be around minus 40 degrees centigrade, and they conclude that we're too beyond their ability range for replication metabolism of known terrestrial microbes. Then it warms up and dries up in the daytime, and so above that, in the top 5 centimeters or so, they get quite a bit warmer. So these are too cold for Earth life. But we don't know the capabilities of Martian life. These conditions are so rare on Earth. And the perchlorates, they are chaotropic agents which help life to help metabolic processes to work faster at lower temperatures. So it's entirely possible, and even Earth microbes might be able to do that as well. It's not very well studied as to how Earth microbes might be able to, and it's very difficult to study the reproduction of life at such very cold temperatures, when it's very, very slow metabolism, and possibly months or longer, or even years or decades, and some life on Earth may have thousands of years before it replicates. That's very difficult to study in the lab, but there might be Martian life in there, maybe slowly living life, or maybe it's quite rapid living and just as faster processes at those low temperatures because of the chaotropic agents, and maybe different biochemistry altogether, which is just faster in colder temperatures. So we can't rule out there's Martian life there, and it's possible, even in the top 5 centimeters, that you could have a biofilm that traps the liquid at night and then retains it in the daytime. And this is what Nilton Renault said, that what does he say? That's saying, yes, here we are. A new study interprets Curiosity's results to show that microorganisms on Earth would not be able to survive and replicate in the subsets of Mars. Milton then sees these findings as inconclusive. He points to biofilms, colonies of tiny organisms that can make their own microenvironment. And the 2015 review, the one that these people just don't seem to be even aware of, it made a similar point. It said cells in biofilms are embedded in a matrix of externally produced substances such as polysaccharides, proteins, lipids, and DNA, and adjust environmental parameters to make them more habitable. Many examples of small-scale, even microscale communities on Earth, including biofilms only a few cells thick. Microbes can propagate in these biofilms despite adverse and extreme surrounding conditions. And this is one of the things that the 2015 review said the 2014 one hadn't taken enough account of. So that is definitely a possibility. There could be little biofilms there, and Earth life could form biofilms too, possibly. And if there's Martian life there already, maybe the Mars Earth life could go into these Martian biofilms and contaminate them. So we can't say that it's safe for Earth life there, in the Curiosity area region. And look, this is about the chaotropic, and that's the 2014 points did have chaotropic substances, and they said that there's a possibility of cell division below minus 18 degrees, and I can't find much research on it since then as to what effect these have on Earth microbes, and whether Earth microbes would be able to, for instance, take up the chaotropic agents from the Martian environment and use them to be able to live at lower temperatures and actually reproduce at lower temperatures, though probably very slowly. The 2014 review and the other ones like this, what they tend to say is that, okay, it's possible, we can't tell the lower limits of life, that's very hard to tell, but what we can say is that if it's very, very low temperature, then Earth microbes would take thousands of years before they replicate. And so they just say, oh well, it could maybe replicate there, but it just takes so long to spread that we don't need to worry about it. So that's what they tend to say about the very low temperatures. It's a very hard limit of 0.6 for the water activity, but there's a very soft limit for the cold, but it just gets slower and slower and slower. And with the chaotropic agents, maybe it doesn't get quite so slow if those are there. So salt-rich brines, and then as we change to the daytime, as the temperatures warm up, so there could be habitable Martian life, there may be habitable Earth life too, although it would only reproduce very slowly. There isn't any real limit to how warm it would get if it can retain this liquid. And so now, just going to go on, recurrence, so I've talked about that, recurrence slope linear, we've talked about that. And then, and this is about why life on Mars need not be related to Earth life. So, the Chicxulub impactor, and it did send material from a shallow tropical ocean to Mars 66 million years ago, but it would be hard for a microbe to withstand the shock of the impact of the impactor into Earth. And the fireball, so you've got to remember, it leaves the Earth's atmosphere at 11 kilometers per second. It leaves it much faster than the fireballs that come in. Once they've slowed down, they become a fireball in the atmosphere. It's going through the atmosphere like that all the way through. So it's going to have to be a fireball on its way out, any material that gets from here to Mars. And then you've got this very sudden shock, change of acceleration is extremely difficult for life to withstand. And that would damage most microbes. Very few that could withstand that sudden change of acceleration, especially very large impacts. Then it's a bit easier because there's an area, but even the area that is less stressed is still well below the surface of what would eventually get into space, maybe with less of this effect. And there's no guarantee it's gone from here to Earth to Mars, and there's no guarantee the other way. We don't know its capabilities. There's stuff that's coming towards us at the moment. Yeah, our meteorites come from at least a couple of meters below the surface, because that's the bit that will go up into space most easily. And it's ejected from the thin south uplands of Mars. And there's the very fragile habitats they're thinking about, like sort of dust and salt and ice, like those Nilton Reynolds salt ice droplets. How's life from that going to get into a meteorite and be sent to Earth? So, and then we don't know what the Mars capability is. Maybe it just falls apart with a bit of a shock, because it's not a natural thing to have on Mars, except for, of course, meteorite impacts on Mars. You could argue the other way, maybe it is shock resistant, but we don't know. We have no idea what's there. It might be that it can't get back to Earth, just can't get here at all. So we don't know that it's related. And whatever these, of course, basically they're not astrobiologists, and if you listen to the astrobiologists themselves, they're designing instruments to look for possibly very unrelated life on Mars. They're not convinced that it's related. So what's the problem? And then 33 seconds in, the thing is, let's do that one as well. A little break from me talking. 33 seconds.
So we have to do all of our search for life activities. We have to look for the Mars organisms without the background, without the noise of having released Earth organisms into the Mars environment. This is why we are very careful when we clean robotic spacecraft, because we really want to understand what's there at Mars and not see the stuff we brought with us by accident.
So that is the problem. I've got the full quote there. So you don't want to. So I now I do a little story about it's a possible future where this is actually, I think, a distinct possibility, although it's fiction, that this could be a real future that we might have if we continue like the way that NASA is planning to categorize Mars. It's consistent with our best current understanding of Mars. So, the first astronauts on Mars, and if it was like me as a child, I had no awareness when I was watching Apollo 11 landing on the moon, this sort of thing. So everyone's cheering, the first astronauts. And I suppose it's a multi-country thing, and put a flag of the Earth, of someone's idea for a flag of the Earth, rather than to make it any particular country. Anyway, it was so exciting, and if it weren't for all this stuff, I would be very excited about this, but I care about science as well. So then you get the Mars astronauts, and they find life, and it's very exciting. Paul Maldonado, the astrobiology mission specialist, announced he found clear signs of life on Mars. It's found in recurrent slope lineae close to their base camp. And it's such a wonderful thing it would be, you'd think, except I'm sure some knowledgeable astrobiologists would be somewhat dreading and sort of expecting what might happen next, because of that long-running debate in Astrobiology Journal about exactly this. Big disappointment. Mars life was from Earth. I'm just depending on the journalist. On closer examination, the life turns out to be a salt-loving microbe sneaked in on the spaceship with the astronauts themselves. It must have got blown in a dust storm that enveloped the camp soon after they got to Mars. Because we get these huge dust storms, and this is something, and so oh how sad, it was just a microbe, an Earth microbe that stuck along for the ride. And I think, do I have a bit about dust storms here, or do I need to add that in? Yes, it's as fine as cigarette dust, and wherever they walk. Now, I think that if we ever do get astronauts on Mars, they'll be surprised at how our rovers are just sort of edging very slowly off over the surface. They don't get this. But if you're driving around like they did on the lunar rover, and you know how the dust went up all over the place for that, and they had these little mud guards, which was plenty enough to protect the astronauts, and when one of those came off, then covered in dust, and all over the spacesuit. But on Mars, it's not going to be like that because of the atmosphere. And look at the clouds of the Martian dust going up in the air. And wherever they walk, they're going to be just clouds suspended. I think, I won't maybe know until we actually have fast rovers there, but I think that you're going to have these rovers zip across, and then for hours later, there'll be this fine dust just hanging where it went. And then that, so the astronauts are going to get covered in dust, and the rovers, and this dust I think is going to just hang in this, just like it does with a dust storm, and take a long time to settle. And then if the dust storm comes along, and then you just need the microbes. They can now last. Now known the microbes can withstand the UV on Mars for hours as they fall down to the surface, and then just get into a shadow of a rock. And then the dust storm comes along, and they probably would stay indoors during the dust storm, but maybe not. Maybe they've got to go outdoors and fix something, and then it all just gets blown over to the nearest RSL. Could easily happen. And if you think of the numbers of microbes, I don't think many people realize quite how many microbes that a human encampment would leave behind. And there is this thing about someone who did a SUV, they went on a journey across the Antarctica, and they were detecting ice, and you get this trotted out over and over again by colonization enthusiasts, and they went and looked at a fair distance away, but they didn't look close to it, and they didn't look like the next day, they just looked quite a long way away, like 10 meters away or something, and then they went off, and they didn't look at what happened later. But if you have a camp like that, and after a 10-day camp in Antarctica, in the dry valleys there, and they keep the microbes enclosed in a corral like that because they want to study the native microbes in that area, and so and it's just earth life, and they keep them corralled, and then after a 10-day camp, this 50 square meter site will have 60 billion microbes, estimate 100,000 per cubic centimeter, and be 0.1 and 10% of the natural population. If there's a natural population on Mars, it might well be much less than on Earth. It would easily end up being more than the natural population in the area where you've been. So when vast amounts of microbes could be blown in the dust. And then, so anyway, so we get to that, so it's no surprise they actually got that. And then, especially if the spaceship crashed, like the Challenger or something. And so then, this comes the next part of the story, native Mars life found, but doomed to extinction. So we tend to assume that native Mars life is going to be robust, but it doesn't have to be. There's always been the idea that we could have a shadow biosphere on, quite recently, last few years ago, it's not so strong now, that there could be a shadow biosphere on Earth of RNA life which came from before there was DNA. And it hasn't been found, but if there could be a shadow biosphere on Earth, there could be on Mars. And there could even be there's nothing else except this RNA world life on Mars. That would be consistent with what if those structures on the ALH 84001, whether if those were actually life, they could be in these tiny cells, RNA world. So it has no DNA, it just has RNA. And so I just suppose that they found this. It's certainly a possibility. Astronauts have found native life in our cell contains RNA and ribozymes, which is different from a ribosome. It's involved in cell processes and making joining things together and making the proteins, making the enzymes and things. So it could be used to make proteins, I think, but on the in this case, you can imagine it's actually involved in actual replication, just like DNA is. And there's no DNA, no ribosomes, and there are no proteins yet. And there's just RNA and various enzymes and various other chemicals, but very simple form of life. And this is no match for Earth life. We just expect it to make it extinct. And this is a possible future. But that's what they find. And basically the idea of a shadow biosphere. And it could be anything that predates the last universal common ancestor. And these it's this like the ALH, this asteroid, this meteorite. That there's still a hypothesis that it could be life. And the cells could be, I've got a little bit about it, yes, the earliest life might have been simple modifiable cells capable of taking up naked genetic material and evolving through lateral transfer by Lanachian rather than Darwinian evolution. That's again my summary of the astrobiology papers that I read on this. And though primitive, it might be the most perfectly adapted RNA world modifiable cells with many specialized enzymes and other adaptations to make it function in an extreme environment. It doesn't necessarily have to be because it's primitive compared to Earth life that it's not able to adapt to these extreme conditions. It could just be a parallel evolution that's managed to do that. The Lanachian evolution, basically, to massive parallel Lanachian evolution, and easy and fast uptake of its capabilities from its neighbours is priority. And the cells wouldn't be in competition, but the genomes within them would be, with a certain amount of genomic protection in small vesicles. And this is conceivably such primitive units of evolution could be represented by small virus-like replicants that populate abiogenic lipid vesicles or inorganic compartments and were subject to selection for replication efficiency. So it's not necessarily even that the cells are particularly living cells. They could be abiogenic, and then eventually they could develop the complexity of the cell. But this could be at the very early stage, where it's working like a cell, and it's got to develop more complexity. And it could even be that it's gone extinct and keeps re-evolving. And we might even find something very primitive there. It's only just re-evolved after going extinct, maybe a few million years ago. That's an idea that's in one of Charles Cockle's papers, that there could be newly evolved life there. And so anything like that could be very fragile, because if you think about it, Earth life would probably just gobble it up. It's got no defences against anything eating it, because there isn't any, hasn't yet happened yet. Nothing has tried to eat it. That's possible. So I imagine that's a very fragile, and so how they found it, then I'm just guessing the story. I haven't actually filled it all in because it's very short, but they could well have just drilled down a bit below the bit that was contaminated with the microbes, or just a different patch of the RSL. They found a little bit of uncontaminated with a sterile drill, and they managed to find this. If there had been even a slight 1 or 2 microbes in it, they were able to live in those habitats. And then they tried to reproduce it in the laboratory, and they fail, because it's not necessarily going to, even though it's been living on Mars for ages, they mightn't be able to create the conditions that it needs. It might need other life forms, it might need its neighbours, it might be you haven't got enough of it. It could very well be like the last passenger pigeons, where there were a small flock of a couple of dozen, and they just didn't produce enough viable eggs for the next generation to keep going for long enough. So for a little while your RNA life is sort of reproducing, but not nearly as successfully as it does on Mars. And it doesn't form, maybe it does form, is able to go dormant, but you don't manage to get it to go dormant in a way that it can recover from. And then it could easily be, and it could even be that it's gone extinct on the journey back to Earth. So you don't get it back to Earth, because it's very difficult to keep it in the right conditions on the journey back to Earth. And that's a possible news story that we could actually have in later this century. Based on the science that we know so far, I don't think there's any way to rule out that that could be a possible future story, which would be so sad. I mean, if any of you know of anything, I've talked about this to various people, I haven't come across anyone who has come up with anything that would be a reason why this is impossible. And so then you say, astronauts regret making Mars life extinct. It's too late to do anything about the introduced Earth life on Mars, since dust storms will spread their spores. So people talk a little bit about the dust, and they say it's not going to spread in the dust, but they don't. There are some toxic chemicals in the dust, but the Earth's spores are very hardy. If you're not talking about necessarily living microbes, but just the spores. And perchlorates are much less damaging at cooler temperatures, and the spore can get into a little crack in the dust. It's by no means been proven that the spores can't be spread in the Mars dust, and very, very possible that it is. And so then I've included this rather sad story from Arthur C. Clarke's Before Eden. I haven't found very much about it, but you might want to read it. It'd be rather long to read the whole thing here, but they travel and they found this wonderful colour kind of carpet of life is actually moving. Now, Martian, according to recent discoveries, the Vladas Zemenkovich, he's discovered the possibility that there could be oxygen in the brines. It's not impossible, maybe not something as brilliant as amazing as this thing that Arthur C. Clarke imagines, but not impossible. You have little sponges and little worms and things in there as well. And tiny, tiny little creatures, especially when you also bear in mind it could be a different kind of biochemistry, and especially in the polar regions where there could be a lot more oxygen if it's very cold. So it's not impossible there's higher life there, and certainly lichens on the surface are a distinct possibility. And for the first time, as they relaxed inside their tiny plastic hemisphere, the true wonder and importance of the discovery forced itself upon their minds. This world around them was no longer the same. Venus was no longer dead. It joined Earth and Mars, for life called to life across the gulfs of space. Everything that grew or moved upon the face of any planet was a potent, a promise that man was not alone in this universe, blazing suns and swirling nebulae. If as yet he had found no companions with whom he could speak, it was only to be expected, for light years and ages still stretched before him, waiting to be explored. Meanwhile he must guard and cherish the life he found, whether it be on Earth or Mars or Venus. And so the happiest biologist in the solar system told himself. But he didn't realise that, and he helped to collect their refuse and put it into a plastic disposal bag and left it on the surface. And then for a while nothing moved, and then his carpet comes and eats their refuse, and then feasted on food more concentrated than any had ever known, to absorb all those things, and the nicotine and the cellulose, and that these back in the days when everyone smoked, and all these it broke down and assimilated without any difficulty. But then it absorbed a whole microcosm of living creatures, the bacteria and viruses, which on an older planet had evolved into 1,000 deadly strains. Though only a very few could survive in this heat and this atmosphere, they were sufficient. As the carpet crawled back to the lake, it carried contagion to all its world. Even as the morning star set its course for her distant home, Venus was dying. The films and photographs and specimens that Hutchins was carrying in triumph were more precious even than he knew. They were the only record that would ever exist of life's third attempt to gain a foothold in the solar system. Beneath the clouds of Venus, the story of creation was ended. This could happen on Mars. Now sad it would be if future explorers on Mars got glimpses of early forms of life on Mars, then they go extinct soon after they're discovered. Or maybe even before anyone finds them. And so it'd be great to say that this is not going to happen, there won't be any problems. And it's what most of us want to be true, and we love to reach science fiction stories and watch movies. And I have too, and it's only fairly recently that I've become really, like a few years back, that I began to become aware. I mean, I'd somehow been unaware of this. Somehow your enthusiasm for space colonization obscures your mind to these things, and you don't see them. It's kind of like a blind spot, which I find hard to understand looking back on it. And I was aware that they did the planetary protection for rovers, but I just didn't even think about it for humans going to Mars. But it's even more so for humans. And so then you have this debate over how could this have happened, and how is it you didn't see it happening. And then there's examples of, for instance, and then the problems of trying to fix it, and that makes things even worse. So that's that. And so what do we do? Well, I don't think that we should be sending I don't think we should send dirty spacecraft to Mars. I'm not sure if I've got that in. I'm going to put that in here if I haven't put it in yet. I've got it in here yet. Oh well, I've got to add that in. 100% sterile landers. So yeah, I've missed out a section here, so I'll pop that in. But it's definitely possible to have 100% sterile landers on Mars, because they've designed them for Venus. And these a lander that can withstand 300 degrees centigrade, not an actual physical one yet, but on paper they've got all the components for it. We have, when people say that our modern electronics is not as robust as Viking, actually we can do much better than Viking. We could build a Viking lander that can be baked in an oven for 300 degrees centigrade for 6 months. They couldn't do that back then. The only reason that our electronics are so fragile is because they use low cost. Naturally, they use just whatever there is, as long as it can withstand what's there. You don't over-engineer to the extent of building a rover that can withstand 300 degrees centigrade if the electronics you're using will do just fine and doesn't need to be hardened like that. But for situations where we need these we need to be able to withstand these high temperatures, like on jet engines or in some parts of electric cars, ICBMs, oil wells where it gets very hot, and inside ovens, and they have little cameras they can put inside an oven. and look at the oven from the inside. And there's all sorts of, they found that everything they needed at 300 degrees C already exists as separate components that have been designed here or there or for the next thing for different things. So we could build a rover that can go to Mars, and it could be sterilized at 300 degrees centigrade for the entire journey from here to Mars. And I think we should address this as a major challenge. There are obviously going to be problems for things like what you do about if you want to have some organics in it that can't withstand 300 degrees centigrade. How do you fill it up, as it were, your experiment? And maybe alignment and things, and people just aren't used to building things like that. But if we really, really want to be able to explore the solar system, and there are probably several places like this, Europa, Enceladus, and possibly Ceres, and then the Mars, then we need 100% sterile landers, because if you're having dozens of missions, then they're going to contaminate it eventually with Earth life if they're contacting salty water. So I think we should have a crash program to develop a 100% sterile lander for Mars. That's my personal view. And then we'll be able to send these things anywhere in the solar system. And I think we should look at them from orbit. So this is the idea. Go right down to looking at it from orbit. Yes. So this is the idea that's developed. A whole mission plan has been developed for that. It's a rather wonderful orbit that comes in and zooms in, and every day it's the same one as very similar to the one that took these photos of the RSLs. It's sun synchronous, and it comes in, it's close to Earth, and it takes these very close-up photos, and you can look very closely, and it goes out around the poles and out again. It's a tilted orbit that's tilted at just the right angle to stay synchronized with the sun. And it does that twice a day. So every 12 hours you're the opposite side of the Mars. You see both sides of Mars every day close up. It's a rather wonderful orbit to be in as an astronaut. Very exciting, because every day you'd see the Mars retreat into the distance and then come right back up again. It's a rather exciting mission. And then you don't have the problem, you don't have the danger of landing, which would be very dangerous in Mars because of the very thin atmosphere. Just your robots land, you don't. You can leave your robot just sitting somewhere for hours on end, which you can't do with a human being in a spacesuit. You don't have to spend the hours of putting your spacesuit on. Many benefits to this. And it's actually more immediate and more direct to do it through virtual reality than it is if you're in a clumsy spacesuit with these gloves that you can barely move your fingers. Very clumsy gloves, they're very hard to manipulate and move your hands inside a pressurized glove such they have to use. They're making progress on that, but it's nothing like virtual reality would be like if you're very close latency and very short latency. And so that's I think that's what we should do. But meanwhile, if we go to the Hadfield, but I don't think we're going to be doing that. I think they're way too optimistic, these people. Talk about Elon time. I don't think we're going to have humans going to Mars till 2040s probably. The next generation. So I'd be surprised if it's before then. And I think it's going to be such a challenge on the moon. And once they realise how much of a challenge it's on the moon, and then you've got to think that before you could send it to Mars, you've got to have a spaceship that could sit just on the other side of the moon, no resupply from Earth for at least 2 years. You know, to have a little bit of margin, and probably more than that to be really safe. No resupplies from Earth, and remember there's no medvac on a mission round to Mars. And if you were leaving Earth orbit, and you had a Apollo 13 type thing went wrong, like a fire or chemical release, or even a hole in your spacecraft, an explosion, anything like that, you've got to keep going for 2 years, or for 500 days anyway, depending on your orbit, to get back to Earth, instead of just the few days that it was with Apollo 13. Can't remember how long it was. I don't think it was more than a week. And so So and Chris Hadfield has put it like this. I think ultimately we'll be living on the moon for a generation. Now, I understand this meaning that when we go to the moon first, the children who are born when we go to the moon, those will be the astronauts that are in their 20s when we go to Mars. I think that's the sort of timescale if you're really realistic about it. And I don't think making a huge big spaceship is going to make any difference there. It's still going to be extremely reliable. Unless, he said, it is as if the world and the moon were threatened, and the only way to preserve our species was to launch from Earth, we could go to Mars with yesterday's technology, but we would probably kill just about everybody on the way. It's as if you and I were in Paris, paddling around in the Seine in little canoes, saying, "We've got boats, we've got paddles, let's go to Australia." Australia, we can barely cross the English Channel. We're sort of in that boat in space exploration right now. A journey to Mars is conceivable, but it's still a lot further away than most people think. And so, no, I can't see us going to Mars before the 2040s myself. And when we do, then I think we're going to be doing, I think the very sensible thing to do is to explore Mars from orbit, unless we've already found out. And the astrobiologists say that returning a sample from Mars is not the way to do it. We're not going to find out much about life on Mars, unless we're extraordinarily lucky and there's life everywhere. But even then, well, we have to sterilize it to return it to Earth. We can return it to above Mars, to somewhere safer, I think above geostationary orbit would be the safest place that we can return it to. But anyway, I mean, suppose it's something like this early Mars life, then it would probably be dead by the time it come back here, and it'd be very difficult to really study it very well. But the problem is, unless it's almost everywhere on Mars, and they're not even going to be digging up the dust, whereas they can't drill down into 5 centimeters. I don't think the successor Curiosity will be able to sample this biofilm if it's there, or these salty brines, just going around drilling into rocks. And you could easily drill 1 meter or 1 centimeter away from life, if there is life on the rocks. And if you can't detect it in situ, which they don't have instruments able to detect low quantities of life in situ, they're not going to know that there was life there to return. And in addition, they are not going to sterilize their sample return containers sufficiently to be sure that there is still a possibility that there could be a viable Earth microbial spore in one of those containers. They're just not going to sterilize it enough to be sure that there isn't. So it's not really I don't think it's really an astrobiology mission. It's more of a geology mission. They might as well sterilize it. And but if they think there's a vague possibility there could be life there, then they could turn it above geostationary orbit, then sterilize half of it and send the sterilized half down to Earth. And the very remote chance there's something interesting there. Because the thing is, they don't know how to detect life there. And their detectors would detect the LH 80011 and the distant meteorite, another interesting Mars meteorite. They would detect those being top priority things to return to Earth. They would take all the boxes that they have. They've pretty much done it by looking at those Mars meteorites and say, this is what we want to look for on Mars. So they're basically going to Mars to find meteorites like the ones we've already got, but with a bit of context which will help. But if it's talking about present day life, they haven't got anything there that will be able to tell it apart. And the astrobiologists say, okay, you might return if you're lucky, because it's not going to be easy to find even things like that, but they might do. They might return. It is possible they can return life with organics in it, and perhaps we don't know enough about what Curiosity has found, but perhaps return something that is as interesting as these Mars meteorites, but an extremely expensive way to return a Mars meteorite, where you could just go and do more searching, more careful searching, try to find them on Earth. And finding the contexts on Mars will of course help. So, but anyway, it looks like we are going to be doing this Mars sample caching and maybe return them, but I think sterilized is what it's going to be, because it's just not legally possible to do it the way they want to do it. And so, yeah, this is about, you can read the rest of this. I think I've said enough. It's getting on a bit. And I just want to talk about how This other bits about it, how the 2015 one, it talked about how there's microscale habitats that can't be detected from orbit. And so we got more ideas about them since then. And even 2014 acknowledged those limitations. That so the new report says. So if you look at this new report, it says Mars should consider how much is category 2. So I hope I said enough to suggest reservations with that. And then it goes on to say that they would actually permit private space to smuggle life onto their spacecraft. That's basically what they say. They say it explicitly. They say that they would be penalised for doing it, but only after it's discovered that they've done it. They say it's impractical for launch providers or satellite hosts to definitively determine the biological content. So this was happened. There was a bad actor in the sense that his Bereshit lunar lander for Israel, he had some tardigrades on board, and nobody told anyone about that. And so this shows that people can do this sort of stuff, whether intentionally. It's no chance of them replicating on the moon, but you are supposed to tell everyone about the biological content of your mission landing on the moon. So if someone goes to the moon and they find some tardigrades, they won't sort of say, where did these come from? They'll know they came from this Israeli lander. So it's it's not such a big deal for the moon. But for the Mars, then this would seem to suggest that the way they're doing it, Elon Musk would send a mission to Mars with lichens on it, just an experiment to see if they survive, and just doesn't tell anyone that he's doing that. And then when they find out that he's done that, they give him a big fine. That doesn't seem a very good way of keeping Mars protected from Earth life. And so I don't think, I'm not thinking that Elon Musk, I think he would want to preserve the scientific interest of Mars. And so I'm not saying that I think he would deliberately make Martian life extinct. But I think you could easily imagine someone doing private space like that, assessing for themselves and listening to astrobiologists and thinking, oh, they think these people there, they think there's could be life on Mars, but these ones say it's sterile, and I'll listen to them, they seem much more sensible to me. And just come to this evaluation that Mars is sterile, which is not a thing that is a consensus in the astrobiology community, and just take that view and just believe it, and then go to Mars, and then do this by mistake. I think that's our main risk here, and I don't think that NASA should reclassify Mars as category 2. I do hope that they reconsider this and change it. And then just a couple of bit more. We don't need Mars as a backup. We've got, these are other places you could go, Titan, Callisto. Mars, instead of Mars as a backup is to restore things. And the moon is an absolutely great place to passively store seeds. Much better than our seed vaults on the Earth. And for far less cost than the cost of a Mars colony, we could set up a few. So this is the other thing, that if you're worried about asteroid impacts, then send up a few small infrared telescopes to look out for the asteroids and speed up our search to find them. Don't go heading off to Mars and saying, well, an asteroid might hit Earth, so what we'll do is we'll try to go to Mars in order to survive. I mean, that doesn't make sense. And Earth is never going to become as uninhabitable as Mars as a result of an asteroid impact. Never. Nothing. It's inconceivable. It's just something like Ceres or Vesta sort of hitting Earth. It's not going to happen. And we've got these ways of protecting Earth from asteroids. First of all, finding them, and then there are ways of deflecting them. So, if we want to protect Earth, protect Earth. If we want to go into space to do space mining, go into space to do space mining. If we want to go into space to search for interesting science, do that. If we want to do it for tourism, do it for tourism. But let's do all that in a way that respects science. And let's not, I don't think we should go, and if you want to go into space to do a backup of your seeds, do it to go a backup of your seeds. If you want to have humans in space as well, a little backup, make a backup colony. And but don't pretend or try or convince yourself that sending humans to Mars is going to be helping Earth as a way of having a second Earth or something. there's no way that Mars is a second home. And if you can do that, then with that background, then hopefully, and that gives us a little bit more leeway to actually be a little bit, not in a huge rush to go to Mars, and we are managing to sort things out on Earth, and to keep going and be positive about Earth and about how we can sort out positive climate change, we can protect Earth against asteroids, and we can have humans on the moon, and then eventually we could have humans maybe in the asteroid belt, and just use all the material in the asteroid belt. There's enough for radiation shielding for 1,000 times the surface area of the Earth. And there's Callisto and Titan and many places we can send humans. And I actually think that it's about the other way around. I think it's inevitable that humans are going to be spreading out through our solar system, even though it seems like it's rather not going to happen right away. I am rather concerned about the other way. Sort of look out galaxy. The humans are coming. What are humans going to do to the galaxy? And that's a whole long other talk. But I think we need to be careful as we go out into the galaxy as to what we do, and make sure that I think if we start off in a good way by protecting Mars and being respectful and careful of whatever is there, and about being like the Arthur C. Clarke said, if we use that attitude as we go to Mars, then I think we may possibly also have the right attitude as we go through the galaxy and find the right way to deal with, which would be a very difficult situation. So where is it? What he said there, I think he put it rather well. The bit. Meanwhile, we must guard and cherish the life we found, whether it be upon Earth or Mars or Venus. To Graham Hutchins, the happiest biologist in the solar system. And this bit about everything that grew or moved upon the face of any planet was a portent, a promise that man was not alone in this universe of blazing suns and swirling nebulae. If as yet he had found no companions with whom he could speak, it's only to be expected, for the light years and ages still stretched before him, waiting to be explored. Meanwhile, he must guard and cherish the life he found, whether it be upon Earth or Mars or Venus. So I think we should explore with that attitude. We should guard and cherish the life we found, wherever it is and whatever it is. It doesn't mean that you've got to preserve microbes, respect the life of individual microbes, but the species and the types of life that we find. We might well find different kinds of life on Mars, and in Venus there's still a possibility of life in the Venus clouds. Remote possibility, but it is possible. Europa, Enceladus, for all we know, they're all different forms of life. If so, I think we respect them all and value them all. And so that is the point at which I'd like to leave this. I'm just a bit over an hour. I didn't want to go more than an hour.